So let's continue to work on Lewis dot structures. So far we've done atomic elements, diatomic elements, and covalent compounds. Now we're going to look at how ions and ionic compounds work in the Lewis dot structure form. Now let's see what happens when we have an ionic bond. For this class, we identify the ionic bonds by starting with either a metal or ammonium. So remember, ionic bonds are where one gives away its electrons, the other one takes electrons. So an ion is anything with a charge on it, where it's gaining or losing electrons. We have something called a cation. Cations are positively charged ions. That means they've lost one electron or more. For example, we could look at sodium. It likes to lose one electron and it becomes a positively charged group. Or calcium, which has 2 valence electrons extra, it likes to lose 2 electrons and become a positive 2 charge. Those are both 2 forms of cations. Anions are negatively charged ions, and those are the ones that have gained 1 or more electrons. An example of an anion might be something like chlorine, which has 1 spot left over ready to accept another electron, so it becomes negatively charged. Or something like oxygen, which again has 2 spots left over ready for accepting electrons, and that gets a negative 2 charge when it's done. In order to make an ionic bond, we need to have one of them that wants to give away the electrons and another one that wants to take electrons. And they have to be equivalent, so that we have this one wants to give 2, the other one has to be able to take 2. If this one needs 3, it has to have something that will give it 3 electrons. So we're going to see that on the next section, how we can make sure that they're balanced out. On the exam, I will not be asking you to write out these ionic bond Lewis dot structures, but they will help you tremendously for us to understand how these compounds come together for writing names and formulas. So let's start with sodium and chlorine and how they come together. Sodium has 1 valence electron, so it looks like this, and chlorine has 7, so it looks like this, with its 7 dots around it. That is what the atoms of sodium and chlorine look like. When they come together, we can see that sodium has 1 extra electron, and that chlorine needs 1 more electron. So if sodium gives its electron to chlorine, they'll both be satisfied. Sodium now has 0 valence electrons, which actually is from its previous noble gas. It's going to look like it has 8 valence electrons to it. And then chlorine now has the extra one, and it has its octet, so it has the correct number of electrons. So we now have the sodium ion with a positive charge and the chloride ion with its negative charge on it. We put them together and we write the formula as NaCl. Notice that I don't put the charges in the formula. So there's nothing there telling you, hey, I'm an ionic bond from the formula. How do I know it's an ionic bond? That is because it starts with sodium, which is a metal. That's our clue that we're doing an ionic bond. Now you try it with magnesium and sulfur. Pause the video for a moment. So magnesium has 2 valence electrons. Let's draw those 2 in. Sulfur has 6 valence electrons, so we draw those in. We see that it needs 2 more electrons to get to 8, because 8 minus 6 is 2. So we're going to see that magnesium is going to give up 2 electrons and donate them to sulfur. And so we end up with magnesium with a 2 plus charge, and sulfur with all 8 dots around it being a 2 negative charge. We put these together and the formula will be MgS, because I had 1 magnesium, 1 sulfur, and they bonded perfectly matched up, so everything is satisfied. So now we're going to look at what happens if they don't match up. So here we have sodium, it has 1 dot. We have sulfur, which has 6 dots. Put our dots around it. We see that sodium wants to give away 1 electron, that's great. Sulfur wants to take 2, that's a problem. So what happens is sodium goes out and finds another friend, another sodium, that wants to give away another electron, so that the sulfur can have its 8, and each of the sodiums goes down to 0 valence electrons, or really the one before it, so 8 valence electrons. So what do we see from this formula? We see that there are 2 sodiums, 1 sulfur. So the formula will be Na2S. How do I know there's 2 for the sodium? We need it to balance so that the charges balance out. So go ahead and try magnesium and chlorine and see what you get. Pause your video. So we know magnesium has 2 valence electrons. Chlorine has 7 valence electrons, and so it only needs 1. So we have one guy that wants to give away 2 electrons and only one that wants to take 1. Chlorine goes and finds another partner, another chlorine, that would like to take an electron, so that we end up with 1 magnesium giving an electron to each of the chlorides, which gives us magnesium with a 2+ charge and 2 chloride ions, each with a negative charge, for a total of 2 negative. When we put that together, we get our formula of MgCl2. For your exam, you will be asked to draw the Lewis structure of 3 different types. Number 1, one of the monoatomic elements. Number 2, one of the diatomic elements, probably oxygen or nitrogen, because I usually like to use the ones with double bonds and triple bonds. And number 3, you will be asked to do one for a molecular compound, binary compound. That is going to be one of the 5 that I mentioned. You will get practice with other ones in your online homework, but one of those 5 will be on your exam, nothing else. And there will be no questions on the exam about the Lewis dot structure of ionic compounds. We'll be doing other stuff with it, but you won't be doing the Lewis dot structure.